So I thought I would make a video on the new Player Unknown Battlegrounds dev report. GPU time, dynamic resolution, level of detail, GPU instancing, culling, all of this is discussed, and I thought I would go over the devlog in a little bit more interactive way and actually recreate some of the designs in Unity to isolate them a bit more than the 2D graphics that were discussed. So on screen here we can see there are multiple emojis on many different cubes. And first of all we're going to discuss CPU times. At the bottom here we can see that it takes 33 milliseconds for a frame to render essentially, and there are many different factors that come into this. This is lighting, VSync, garbage collection, physics, scripts, all from the CPU level. Now this is essentially what they're trying to reduce. The more CPU time you use per frame, the lower the frame rate is directly impacted. And my thesis actually discussed this a lot, so this is an area I'm kind of interested in. Now on screen just here, instancing is something where you're going to copy and paste essentially the same object over and over in the GPU. Now this means that you do not have to re-render that object over and over again, which increases CPU time because you have to re-render it. So rather than that, we're going to use instancing, which just copies and pastes it. And on screen here, this is not using CPU instancing. Now I want to just elaborate that. It's not always the best case scenario to use. At the moment we're getting 35 frames a second. Now if we enabled GPU instancing on the sprite, we can see our frames will probably take a dip. We're going to get a spike here. Bad example because we can see the explosion, there's less things being rendered on screen, but everything is running slower. Now if we disable it again, we're going to bounce back, the frames will probably improve a little. Now this is because we're using a sprite sheet here in the corner, which means there are 16 different emojis icons that are being rendered onto randomly selected cubes in the scene. Now this sprite sheet is large, say it's 1 megabyte, and we're just actually taking a cut of it when we're not using instancing, which means it's going to be very small, 10 kilobyte. Essentially, when we enable GPU instancing, this whole sprite sheet is being rendered with each one of these cubes. So rather than just ending an area of the sprite sheet, we're rendering the whole thing. Highly inefficient. Now, what's it like if we actually enable GPU instancing, like in the PUBG example? Now, here on screen, we have this feature exactly implemented. So rather than using trees, we have cubes here, and there are a lot of cubes, and our frames are massive. Now, in comparison to the other one, they're moving around. We have some other 3D models being procedurally rotated and stuff. And if we look down here at the floor, let's pause this so we can have a look. We're going to look at the material here, and we can see this is a custom shader. So, and actually what's happening is in code, we've enabled GPU instancing. On our material here, if we enabled GPU instancing, we would get the same effect. But rather than that, we've just created a shader that has GPU instancing automatically enabled. Now, we aren't using a sprite map, we're using a single text material here, which means that we're able to create multiple instances of these cubes with only rendering it once and then changing the color using a gradient in code, meaning that we can get this effect where we have hundreds on screen with many different effects using one material because it's only stored in memory once, a very small amount, and it's just being able to recreate it and create multiple instances of the cube on the screen. As you can see at the top here, our frames are extremely high in comparison, and also we're using 1 milliseconds over our previous demo, which uses about 33. So this is for culling, sorry. So we're using about 4 milliseconds. So as you can see, our CPU time are lower, which means that we've used instancing in a great scenario in comparison to using a sprite sheet where each shader will be rendered with a much larger memory. This is saying that sprite sheets are fantastic to use, but not in instancing. Now let's take a look at frustum. Now they mentioned that they were only going to be rendering areas specifically. Now if we take a look at our camera, this frustum on the screen here, we can see is going out here. So when we use an 8x scope, we're seeing, when we're using a normal scope, we're seeing all of this that's being rendered on screen. But when we're using a normal field of view, we can see everything. And then when we use an 8x scope, we're just narrowing it down to only rendering specific objects and trees that we want to see. So when we're looking at trees from a distance, we're not really going to need to see all the detail. I can't make out those little circles on that little model in the middle just now. But if we did zoom in, we would be able to make out the details. Now how does this work exactly? And you know, as you can see, it's obviously beneficial to not render the little circles on screen, and then as we zoom in, they're going to improve in quality because we can see more detail. Now, how do we do this without impacting performance? So the way we do this is by using level of detail system. Now, a level of detail system essentially swaps out models for a lower triangle or poly count, which is much easier to render. Now, our level of detail system here has a sphere which has 80 triangles, and then the next one has 24 triangles, and then eventually we're going to cull it completely because the tree, in an exaggerated simplification of the player no battlegrounds, will not be in view, so we don't need to render it. So far away, like when you jump out of the plane, you don't actually need to see the tree. So at the moment we're in the plane, we don't see a tree, and as we get closer, we want to render the tree, but at a very low polygon count, so we're not impacting performance as there are still going to be quite a lot of trees on screen. And then as we get even closer to the tree, we want more detail to show, so now we have 24 triangles, so now we can see the tree's detail in its full. And then as we move away again, we're going to reduce the quality of it, and then as we move further away, we're going to completely stop it. Now obviously these two models aren't very similar, but sphere and this little ninja star are both used to exaggerate it, so you can clearly see that the model has changed and the quality is different. I hope you have found this video informative and I enjoy sharing. I apologize for the mic quality. I am working remote just now, but I intend on creating more Unity development videos and discussing some systems that you may have not heard before in relation to general game development. So thank you for watching.